Yay. And here what we do, excuse me, is we don't tell the system how to do things. We tell it what we want it to look like. We say, I want these 10 accounts to be on every machine. And they have to have these attributes. This account has to have this user ID. This account has to have this password. This account has to have this home directory. And we put that in a list, and then we can just say, all right, apply that to a number of machines. And we don't care about the details of how that actually happens as long as it happens. For all we know, it's actually black magic. Somebody's drawn a pentagram around the machine, you know, secret incantations. I don't care. As long as a machine ends up in a known state, the state I want. So basically, your chef, your CF engine, your Puppet system, it's going to handle the details. Now, the catch, of course, is it's going to handle the details on the systems it knows how to talk to. So Puppet is not going to help you with Windows 2000. At this point, almost no one will help you with your Windows 2000 servers. I know you still have them, and shame on you, and I know why you still have them, but really, please, that ship sailed a long time ago. So we tell the system what we want the end result to be, and this is where my objections often come with Chef, but we get a common framework for resources. So generally, these systems will define a resource like a user or a file or a service, and then we just tell it the properties we want it to have. Say, I want to create a service that runs this program and listens on port 80. Great. All right. That is a resource definition that the DCM system will know how to define on any supported client. So it can do it on Windows 2008. It can do it on your Red Hat 5 machines. It can do it on SUSE. It could do it on AIX, whatever. And the neat thing is, these systems run periodically, usually every 30 minutes, usually every hour. And every time the client checks in with the server, it says, hey, boss, hey, what should I look like? And the boss hands them the list and says, here you go, here's your instructions. Chef calls them cookbooks, Puppet calls them manifests, CF Engine calls them promises, last I looked. Doesn't matter. Here's your list of instructions. And the client starts at the top and goes, awesome, okay. Do I have a user like this? Yes. Do I have a service like this? Yes. Do I have a firewall rule like this? Yes. And at the end, it uploads its results, including everything it changed. And if it couldn't change it, well, it uploads that result too. And hopefully somewhere someone's pager goes off and somebody, well, hopefully not me, because I don't like my phone ringing in the middle of the night, but someone gets woken up and it says, hey, there's a new account with root level on this machine and I couldn't delete it. So, yeah. So we only log the remediation. We log our remediation. We only warn people if it fails. These systems are brutal to build. I actually worked with one that was handmade years ago. It was a series of shell scripts, and it was spectacular. And it managed a couple of hundred retail machines beautifully. But adding a new system into that did require human sacrifice and black magic. I mean, it was a complex code base. And that's where the Chef and the Puppet and the CF Engine guys are ahead. They've already built this. They already have other customers. So why reinvent the wheel? There we go. And I keep saying, why reinvent the wheel? Because I'm lazy, that's why. And this is another big one. I can sit down right now and I can sit down at all your Unix systems and I can add a user to your specifications on all of them. And it'll take me a few minutes because I got to type the commands manually. But I'm going to have to stop and look. I'm going to have to look at the differences for each version. So if I want to do OpenBSD, I got to look at the exact syntax of the user add command on that machine. And then if you want me to throw Windows 2012 R2 in there, well, that's going to take me even longer. I can do it, but I need OS-specific knowledge. And that's an expensive thing. A lot of stuff we do on machines is common stuff. We're just making sure that files have given permissions, services are still running. Right? That, if we can abstract away that OS knowledge, we can take people who are expensive, like me, and minimize their use so we can save everybody a lot of money. And this, better reporting. Oh, I love good reports. Reports are lovely, especially when they tell me that everything's fine and everything's the way it was last week. The best The best Puppet run logs I see are the ones that say no changes made in 3 days. Oh, that's awesome. I like that. It's a very static state. This is my favorite word, idempotence. I love this word. And I'll get to it more in the next slide. But this is another thing. Avoid digital micromanagement. I mean, that's what, if you're writing scripts to configure all your machines, it's really what you're doing. You're digitally micromanaging your machines. Get a smarter tool. I actually had a guy once who stood behind me and told me how much more efficient it would be if I would mouse with my left hand. It was almost a 15-minute lecture. I actually had to start mousing with my left hand to get him to leave me alone. One of the other developers at that company listened to about 5 minutes of that and then finally said, how efficient would it be if I have to pull the mouse out of your throat before I mouse? And so the guy had to then give up on him. But the guy who said that was also 6'2" and 320 pounds. So something like that from him carries a little more weight than it does from me. So idempotence. I love this word because it sounds like you need to go to a urologist, but you don't. What it means is no matter how many times I run the script, I get the same result. So if I got a script that adds a user, I run it once, that user's added. I run it a second time, nothing happens because that user's already there. Ooh. This is a really big thing, and this is super hard to do when you're just writing your own scripts. There's a lot of guys out there who can write awesome batch files and awesome Ruby scripts and shell scripts and everything else. And that first run of the script, that's the easy one. Because you start with a clean machine, you get the result you want. All right, now you got to go back and you got to say, well, what if it broke at any one of these 6 points the first time? Or what if things out of space? How do we make sure we always end up in a known state? And so I like idempotence in all capitals because it's very, very important. So I do know guys who can code scripts that way. I've written scripts like that, but it takes a lot of work. And it just takes one mistake, and your script is no longer idempotent. And now, limiting our need for OS specialists. This is a really cool thing. I'm actually working on a project where I'm doing a bunch of automation on Windows, which is really weird because I'm a Unix guy through and through. And I'm actually using Puppet to install a whole bunch of Windows software and force a bunch of registry keys. I honestly don't know what the registry keys do. But these guys tell me that it's really important. And after the manifests run, they say it's working. This is great. We didn't have to get a guy with specialized Windows knowledge yet. So cool. We didn't need that guy. Years ago, if I would have needed to do that, oh Lord, I would have had to dig up my script on WMI, or my book on WMI and all that active script stuff that I worked with once and don't really remember. So, I mean, you still got to know some stuff. I mean, I had to know what looks right for a registry key, but I don't need to know the nitty-gritty. And I already used my example of adding users on Unix. You're going to have different commands on OpenBSD and Solaris and AIX. But at the end of the day, I don't care what the commands are. I just care what the result is. And here's some of my sample reporting here. So I have a very small fleet in this picture. I got a population of 9 nodes. Not many machines, but that's getting to be enough where if you can't remember what every machine should look like off the top of your head, you should probably start thinking about doing something like this. And I've got 4 of them that have changed. I know exactly what happened there. I added a user to all those machines. This is the scary one. Goonybird is marked as failed. So that's going to require one of your specialists to look at it and actually intervene. But from here, I can click down. This is actually an open source project called Puppet Board. It is part of the open source version of Puppet. You can actually implement this without paying the company for anything. If you want to buy their fancy enterprise version from Puppet, it's $100 a machine in a year in perpetuity, or you can use the free stuff, and then you just got to throw something like this together. But here I can get my reports, and it'll tell me what the status of these machines is. And I love a report like this. And I'm one of the technical guys. Management types love these things. Look, green, red, we can see clearly what's going on. That's perfect. There we go. So the logical view of really any DCM system. We define what we want, it gets implemented, and it goes straight from implementation to remediation. It just keeps it that way. It's like a guy walking around on your wood floor. Every time he sees a nail up, he just whacks it with the hammer, puts it back into place. And people will complain, but that's the point.